6.2, adding integers. So adding integers, and we saw those zero pair thing, right? If you take an opposite and add it to its opposite, well, you get zero out of that, right? Like these tiles like this, positive and negative tiles. I mean, they combine to give you a total value of zero, like we saw with that -4 business. So negative zero out positives and positive zero out negatives. Yeah, it goes either way. It doesn't really matter which one you start out with. But if you wanted to make zero, then you would. Now this is important because you'll see when we start adding opposite values like negatives and positives that some of the negatives will cancel out some of the positives, or some of the positives will cancel out some of the negatives as zero pairs. So when we say cancel, sometimes we refer to making phantom 1, sometimes it's phantom zeros, or zeroing out like we will with adding integers, okay? Now that's only if they're opposites. We'll find different rules to use on these when we add the same types of integers. So on this one, right, we got -2 plus -4. So yeah, I'm going to write this down here below, and then we'll kind of work with it. So -2 and 4, I'm going to start with just the two values individually. And the first one here is -2, right? So I'd have not only one negative tile here, but also a second one right here. So that totals as -2 right there. But in addition to that, we got the 4 positives, right? So there's one positive, and pull out another one. There's 2. 4. There we go. 4. Okay. Now we are adding these together, which means that we can start combining these and seeing if anything zeroes out. All right. So I'd say, well, move this over here in this one. Okay. And what happens is that, well, it's got a 0 right there. That pair, +1 and -1, and there's a positive and a -1 as well. So what's the final value on this? Well, there's 2 positive tiles left over that were not zeroed out. And so you just have a +2 out of all of this, okay? So that means that -2 plus +4 equals 2. And of course, you can say +4 on this, but it's okay to say -2 plus 4 equals 2 as well. But again, since we don't see the sign of the 4, we would know that it's positive. We should know that. So this is nice to use tiles like this. You'll never be required to use tiles. Not on the assignment, not on any quizzes or reviews, nothing like that I can ever see. I did not see anything like this on the assignment. But for some of you, it may help you to make these connections until you get some of the rules down, which we're going to show you some of the rules here in a moment. But before we do, let's do another example here. And so what is this? -1 and +2. Of course, we are adding these together. So let's look at these as what it would look like with tiles, right? So I'll say, well, there's a -1 right there. Then I need 2 positive tiles over here. 1, 2. All right. So once again, we are adding these together, which means that we can combine them. So I'd move this negative over here, combine with that positive, and that becomes a 0 pair. So what are we left with? Only one positive that I can see. So +1, again, we don't need to show the positive sign. It's just +1 or 1. Now, you should notice something from these past two examples, and it's not a lot of data to go off of, but it's enough, hopefully, that you can see that when we add opposites, which is what we're going to be looking at here in the future, it's important to identify which of the two values, negative or positive, is bigger. Not in terms of least to greatest, but just in terms of sheer size, okay? Because when we're adding these, see how we brought these together, which made 0 pairs? But the answer was positive because we had more positives. If by chance we had more negatives, then we would know the answer is a negative. Okay, but when we're dealing with opposites, what happens is we end up using subtraction, which we'll show you. And that's what this slide is telling us right here. The sign of the sum will be the sign of the bigger numbers, as long as we're dealing with two numbers. Okay, so you'd say, well, which of the two numbers is biggest? Again, we're not looking at least to greatest, just, again, sheer size, which really is an absolute value thing. So you'd say, well, if the negative number is bigger, then the answer is a negative. If the positive number is bigger, then you would make the answer a positive. That's the first step when we look at adding with opposites, meaning negatives with positives. is determining the sign of the answer. And it'll be true even if we're adding the same signs, okay? Just the first thing you need to do is determine if your answer is positive or negative. Now, if they're opposites, we're going to subtract these. You're going to take the big number and subtract the small number. Why are you going to do that? It's because, like we saw with the tiles, is the small amount will cancel out or zero out, right, with the zero sum, or zero pair. It's gonna zero out as many of the big number as there are of the small one. So we're just gonna subtract those two, and whatever we get from that difference is our final sum, just with whatever sign we found from the first part. Okay. So there's really two parts to this. The subtraction should not be a problem because we should be pretty familiar with subtraction by this time in the class. But we need to determine if the sign is positive or negative of the answer. That's the first thing we're going to do. So here we go. Three good examples on this one. Okay, let's start with this first one. So again, the first thing we should do is determine if the answer is positive or if it is negative. And on this one, just comparing these two values, I see that 28 is bigger than 21. So I look at the sign of 28. It is negative, so I know that my answer is negative. Okay, that's the first step. After that, since they are opposite signs, 28 is negative, 21 is positive, I'm going to take the big number, 28, and I'm going to subtract the small number, which is 21. Whatever I get out of this difference will be the numerical part of our answer. Of course, we know the sign is already negative. So 8 minus 1 is 7, 2 minus 2 is, that zeroes out. So I end up with the final answer of negative 7 from this one. Okay, so, well, again, don't forget, why are we subtracting on this? It's because these 21 positives are going to zero pair with 21 of these negatives, and you'll have 7 of the negatives left over. That's how we get that value. All right, this one's nice. I mean, it's smaller values, but I mean, it still follows the same process. You could use the tiles if you'd like, especially with smaller numbers. But you've seen already, even on that last problem, is it becomes kind of impractical to use the tiles because, well, I mean, putting out more than 10 tiles is kind of rough and can be time consuming. I'm not saying that you can't. It's just it becomes kind of an inconvenience. But if you prefer to use the tiles, feel free to do that. But again, we're focusing on the method right now. So negative 6 plus 3, just comparing the two numbers to determine if the answer is positive or negative. I see 6 is bigger than 3, and 6 is a negative sign right there. So I know that my answer on this one is going to be negative. Then all I do is take the big number and I subtract from it the small number. So that'd be 6 minus 3, which you should know is 3. And if you need to use fingers on that, feel free to do it. But 6 minus 3 is 3. So again, our final answer here, negative 3. Now again, we see this negative in parentheses. That's because, well, if I were to show this, I'll see if I can type this in to kind of demonstrate why this needs parentheses, because if you type it in without the parentheses, this is what it looks like. 20 plus negative 64, and I have purposely moved these close together, but you'd look at this and you probably wouldn't be able to determine what operation we're using. Are we using addition? Are we using subtraction? What the crap is going on? Well, the parentheses help us to make that determination. So that's why we see the parentheses right there. That's why we will see the parentheses. So you should probably expect to see those in the future when we're dealing with negatives. Now, the first number doesn't always have to show with parentheses, but it just might. You should probably expect to see some of those types of examples in the future. So we are definitely adding 20 plus negative 64. Now the 64 is the bigger of the two numbers, and the 64 is negative. So once again, I'm going to first label my answer as a negative. And then I take the bigger of the two numbers, which is 64, and then the smaller of the two numbers, second, 20, and I subtract these two out. Okay, these 20 positives are going to zero out 20 of those 64 negatives, and so that's why subtraction. 4 minus 0 is 4, 6 minus 2 is 4 as well. So again, my final answer is just negative 44. Bam. All right, so that those were adding with opposite signs, right? Positives and negatives. Now we're dealing with adding with the same sign. Now think about this, and yeah, you can read that, but we've already dealt with adding with the same signs with positives, right? Like if I said 3 plus 7, right here, you should know just basic arithmetic. That's 10. You use fingers if you need to. Now, since we're focusing on signs now, you say, well, 3 is positive, 7 is positive. We're adding the values with the same signs, which came out as positive. That will be true with negatives as well. So if I took, let's say negative 5 and negative, I'll make it negative, I don't know, 11. That seems good. And let's say we added these together. I'll use parentheses just to kind of formalize that. So on this one, we'd say, hey, look, these two are both negative, so the answer should be negative, right? And then you'd say, you take the two values, 5 and 11, and you'd actually add those two together. 5 plus 1 is 6, drop the 1, and you end up with negative 16. Now, since we're focusing on the sign, remember, if you're adding two values that have the same sign, the answer will have the same sign as well. Well, why is that? It's because if you start out in the negatives and you pile on, I'm using a different terminology for plus, but if you take a negative and pile on more negatives, you just get a bigger negative number. Same with positives, right? If you start with a positive number and you pile on more positives, you get more positive numbers. I feel like there's a compound interest lesson in this, but we'll save that for a later class. So here we go. 3 examples, all with the same signs in each of the 3 examples. Of course, this first one is one that we should be able to do almost by heart, because that is some basic arithmetic. If you still feel the need to use your fingers to do this addition, then keep doing that until you feel more comfortable that you wouldn't need them. All right, so 8 plus 9, again, I see the 8 and the 9 are both positive. Well, I didn't see it, but we would know it. I still put the symbols there, so I know the answer is positive. 8 plus 9 is 17. All right, and again, we don't actually show the positive symbol in our answers, even when we're doing this on the assignment as well. So be aware of that, okay? All right, here we go. Negative 1 plus negative 5. So again, I just determined the sign of the answer. That's the first thing I want to do, and then we operate with the numbers, okay? So I'm dealing with addition of the same sign. They're both negatives, so I know that my answer should be a negative. We will show that sign, of course. Since they're the same signs, I'm going to take the two values, 1 and 5, and add them together. And 1 plus 5 is 6. So my final answer here, negative 6. Negative 14 plus negative 27. Again, the first thing we need to do is determine the sign of the answer. Both of these are negative, so I know my answer is a negative. Then I just need to take the two numbers. Since it's the same signs for both numbers, we take the two numbers, 14 and 27, and we add these together. 4 plus 7 is 11, carry the 1. 1 plus 1 is 2, plus 2 is 4, 41. So combining that with the negative that we found before is a negative 41. That'd be our final answer for this one. Now, it's possible to use the commutative property of addition with negatives as well. It doesn't matter if values are negative, positive, decimal, fractions. You can always use the commutative property as long as you're using addition or multiplication. But it's also possible to use the associative property. Now, the associative property, I use this generally just working from left to right, so I'm going to use both methods. The commutative property actually allows us to rearrange values. So while we may be dealing with more than two numbers at a time that we're adding, we can kind of rearrange them. Well, why would we want to do that? Well, we'll see on the next example. So let's do this top one first. Negative 48 plus negative 5 plus 71 plus negative 16 plus 32. So 3 negatives and 2 positives. All right. Now, when working with a lot of values that are being added like this in the same problem, I like to start, at least if I use the commutative property. So I'm rearranging these, right? Well, rearranging means that I'm just working with pretty much one type of value, meaning positive or negative. So I say, hey, look, I'm going to start with the negative numbers, and I'm going to combine them all, right? So this is all addition. So I got negative 48 there. I also have the negative 5. Those two were the first two anyways. but I also have this negative 16. All right, now we are dealing strictly with addition right now. But I can add these numbers together to figure out what that would be. All right, now this is going to simplify this from 5 values being added into 2 values being added. One will be negative, one will be positive, because I'm only focusing on the negative, and then I'll focus on the positive, right? Well, since it's all the same sign for each of these, I know that the answer will be a negative, all right? So I'm putting that negative in right now. So all I've really got to do is take the numbers and add them together, because they're all the same sign. So that would be 48. I'm going to just do the first two. I'm going to do 2 at a time. 48 plus 5. 8 plus 5 is 13. Carry the 1. 1 plus 4 is 5. 53. But then the 16 as well. Let's add the 16. 3 plus 6 is 9. 5 plus 1 is 6. I almost put 4 there. It's 6. So that's a negative 69 from just the negative values, right? So right now, from what we have, I know that the final 2 terms, one of them, the negative value, is the negative 69 that we just found. Okay, but I got to find the positive value as well. All right, and there's a couple of positive values there, 71 and 32. So let's separate these two, 71 and 32. I'm not really aligning these up because it's a slide and it's not lined paper, but this lined paper is probably a little bit more pretty. And yeah, we're going to add these together. These two are it's just 2 straight positive terms, positive numbers, and so I know my answer is positive. I've got to take the 2 numbers and actually add those 2 together. So that'd be 71 and 32. Let's add these together. 1 plus 2 is 3. 7 plus 3 is 10. So 103, positive 103. And that would be the second number in this problem, 103. Okay, so I got a negative 69 plus 103. I got just enough room to put the answer to these 2 in there. And let's see what we get. Well, the first thing we would want to do is determine the sign of the sum here, these 2. So I'd say, well, 69 is smaller than 103. 103 is bigger. It's positive, so I know my answer should be also a positive number. Now I'll get rid of that positive, but I'm putting it there so I know my answer is positive. And from there, I take the big number, 103, and I subtract from it the small number, 69. So we're going to subtract these 2, and whatever I get from this will be my answer. Now 3 minus 9, I'm going to borrow from the 10 there to make that 13 minus 9 is 4. 9 minus 6 is 3. 34. Positive 34 specifically. And that would be our final answer. I kind of tossed out that positive sign because we don't need it. But 34 positive, that is our final answer. So on that last example, I used the commutative property pretty much to rearrange the values, essentially group them together however I wanted to, which is also kind of the associative property. So, but on this one, I'm strictly working from left to right, which is by itself the associative property, okay? Which means that the first thing I'm going to do is operate first just between the 9 and the negative 3. I'm only focusing on that. The other values I am not going to touch yet. I'll get to those, but I'm not going to work with these just yet, okay? So I'm going to set that aside, and whatever I get from the sum of 9 and negative 30, I'm going to put that in this spot right here, okay? Well, we've got to figure out what that is first. So, well, let's do that. Let's do 9 plus negative 30. I know I'll need more space. We'll get there. 9 plus negative 30. Okay. So these are opposites, and the negative 30 is bigger, so I know my answer is negative. From there, I just take the 2 numbers, the big one, 30, and then subtract the small one, 9. So I'll borrow from the 3 to make that 10 minus 9 is 1, drop the 2, 21. So negative 21 is what we get from the 9 plus negative 30. So that was 5 numbers being added together. But now we just changed it into 4 numbers, right? And we're going to keep simplifying this 2 at a time until we get to one individual value. I feel like there's a good March Madness reference here, but I'm going to skip it. So, so again, I'm just focusing on first 2 numbers here, negative 21 plus 6. And so I'm not really worried about the plus negative 7 plus 2 yet. I'll get there. I'm not worried about that yet. I just want to simplify what we have so far. All right, so this is in the equal, and whatever I get from the 21, negative 21 plus 6 will go into this spot right here. Okay? So let's go ahead and set that up. It's negative 21 plus 6. All right, well, I see that the 21 is negative. It's bigger than the 6, and it's negative, so I know my answer is a negative. And from there, since they're opposites, I'm going to take the 21, the bigger number, and subtract the smaller number, 6. So again, borrow from the 2. 11 minus 6 is 5. Drop the 1, 15. So we do get negative 15 out of that. And now we've changed this we went from 5 numbers being added together to now only 3 values being added together. Well, once again, I'm going to focus on this 2 numbers at a time, specifically the negative 15 and the negative 7. So whatever I get out of this, of course, I'll still have to add this to whatever it is, but we got to figure out what that is. All right? So this is negative 15 plus negative 7. There we go. Now on this one, we are adding the same signs, which means it's going to keep the sign, and the signs are negative. So there's negative, but the 2 values, instead of subtracting like we were doing before with opposite signs, these have the same sign, so we're going to add these 2 together. 15 plus 7, 5 plus 7 is 12, carry the 1, 1 plus 1 is 2, 22. Negative 22 specifically. So now the problem from 5 values being added to now only 2 values, negative 22 plus 2, and when I add these 2 together, of course, we should have our final answer on this one, so whatever it is, okay? Now on this one, I can see that the negative 22 is bigger than the positive 2, so that means I know my answer is going to be negative, okay? So I put my negative sign in my answer, I take the 2 numbers, the big one, and then I subtract the small one, because they're opposite signs. 2 minus 2 is 0, drop the 2, make that 20. Just it's a final answer of negative 20 there. Bam, we did it. Now, do remember that we're never going to require any specific method. So even if you're like, hey, I'm going to set all of this stuff up with the tile thing, feel free to do it, okay? It will be extraordinarily time consuming, but you can still do it, okay? And in fact, there's even ways to take shortcuts with tiles, but I'm not going to get into that. I almost don't want to encourage it, but if you feel like you want to, feel free to do it. So up here where I use the commutative property, feel free to do that if you like it. I tend to make more mistakes myself when I use this method, as opposed to just doing it from left to right, 2 values at a time. And you may say, well, it's a little bit more work. Okay, but if you understand to do it better, then do it. Okay, or if you make less mistakes using that method, then do that.